Thank you. When I walk in the forest, I'm over 100 feet tall. I can see over the brush and shrubs and over the tallest trees. I can look at things close up, across a lake or way up a mountain. My name is Matt Sackles, and I'm a research geomorphologist. That means I study the surface of the Earth and the way that it changes. Through my geomorphology research, I came upon drones as a way to quickly and safely gather data at difficult field sites. And I got excited. I saw that drones could benefit much of the work of the provincial government, so I've been working hard to share and develop the use of this technology ever since. In fact, we've now trained up over 140 drone pilots ready to go to work province-wide. And I've been reclassified as not only a research geomorphologist, but also the provincial drone specialist. Today, I'd like to talk about 4 big ways I see drones helping natural resource professionals. Number 1, situational awareness. Imagine you're on a wildfire fighting crew, and you have no helicopter support. They're too busy on other fires. As you're nearing the provided coordinates, you look up the hill and you see some smoke, and you think, how big is the fire? How do we get there? Is there any water around? With our drone and the help of BC Wildfire, we can put the drone up. We can decide how many crew we're going to need to fight that fire, how we're going to get them there. We can even find a nearby wetland to act as a water source. The little drone will be a big help. When we investigate a field site, we develop a concept. We build a mental model. Not only can drones help us build that mental model faster and better, they can also help us convey it to others. That brings us to number 2, communication through photographs and video. This mental model we build of a site, it's difficult to capture with a handheld photograph. It just captures a small view. When we work with others, much of our time is spent communicating what is left off of those handheld photographs. With our drone, our photographs can now convey more. I like to call it 20/20 vision. When I put my drone 20 meters up and 20 meters out and take a perspective photograph of my field site, my experience is much better portrayed. For example, I was asked to go look at this soil disturbance issue. Here's what it looks like from the ground. Now I could take a dozen photographs and provide a map with the perspectives and positions of each photograph, but it would be very difficult to comprehend for my audience to build that mental model of the site. It's likely many of them will start glazing over and thinking about their weekend plans. Certainly hope no one's thinking about their weekend plans right now. Because here comes my drone. Now, not only do I have better situational awareness of the site, but by capturing this photograph, I can now share that with others. Number 3, mapping. With a few taps on my tablet, I can send my drone over a site on a predetermined grid route, automatic flying. It flies automatically. It will also automatically cue the camera to take photographs at the correct position, so I get the specified level of overlap between photographs and between flight lines. Here, the blue icons are the positions where the photographs were taken. I then take these photographs and I put it through a particular software. It helps me develop a photo map or an orthophoto and a 3-dimensional model. Here, a model of a placer mine made up of about 17 million points matched between 150 photos. By doing this repeatedly at the same site, I can watch the surface of the Earth change by differencing these models. This is like a dream for a geomorphologist, and for anyone who deals with volumes of material moving across the surface of the Earth. It works great where the surfaces of interest are hard. There's not a lot of vegetation around. It doesn't work great over forests. Let's investigate this a little further. When my drone flies over a forest, it's looking down on the tops of just a few trees. For the remainder of the trees, it's looking at the sides. This is largely because drones can legally only fly to 120 meters above ground, and that given that trees are, say, 30 meters tall, the geometry is not in our favor. In the subsequent photograph of the survey, the drone will be looking down on the tops of some of the trees it was previously looking at the sides of, and vice versa. Unfortunately, the result is that the trees look different enough in the successive frames that the software can't make a solution. So we get no orthophotograph, no 3-dimensional model, no fun. Recently, we've received authorization from Transport Canada to fly our drones higher, up to 700 feet above ground, and capture photos like this one, where my drone is looking down on the tops of more trees, enough trees to be able to create a solution. This is fantastic because it allows us to start characterizing forests and working collaboratively with forest researchers to put data into our timber supply and other models. So for the first 3 points, any field drone will do. I like to call them field drones because they're small, relatively cheap, and portable. Typically, they fit in a backpack. One constraint field drones generally have is they have a single standard camera on board, and you can't change it. For this 4th point, we're going to have to step up our drone game to drones with interchangeable payloads. A payload is anything on board an aircraft that's not required for flight, such as a passenger, a camera, maybe an air quality sensor. Or maybe you're interested in foliar samples or cone samples from the tops of trees. We could climb the tree, but not safely or productively. With a conventional helicopter, it would be possible, but terribly dangerous. If we were over 100 feet tall, we could just reach over and snap off a branch. Not being 100 feet tall, we've got to come up with another solution. Enter our high-dollar drone with a mini harvester head attached on a lead. Now we can sample from the very tops of the trees safely and efficiently. In conclusion, while drones aren't perfect for all field work, I feel they can increase our spatial awareness, leading us to more effective field time with less time looking at mundane subjects. I feel drones can capture the essence of the field visit and convey it to others better than any other method right now. Drones are an incredible means of collecting detailed mapping of the surface of the Earth, and now, with our 700-foot authorization, of the forest as well. I think we've just begun to discover what drones can do for us in the forest. But most of all, I love being over 100 feet tall when I walk in the forest. It makes me do my job better. Yes, thumbs up to drones. Thanks.